Today we're going to talk about reaction mechanisms. Many reactions don't occur through a single step, but they occur through a series of elementary reactions, and these reactions add up to form an overall chemical reaction. Now, the overall equation, it's useful for studying things like yields and quantities and stoichiometry and all those things, but it's not a reflection of what is actually occurring on the molecular level. Although the overall reaction can tell us something about what bonds were broken and formed, we only see the beginning and end of the process. We can't tell what steps occurred during the reaction just by looking at the overall equation. A reaction mechanism describes the sequence of elementary reactions that must occur to go from reactants to products. Reaction mechanisms will often involve reaction intermediates and/or catalysts. We talked about intermediates in an earlier video. An intermediate is a species that's formed in one step of the reaction mechanism, but consumed in a later step. Experimental detection of a reaction intermediate is a common way to build evidence in support of one reaction mechanism over an alternative mechanism. But remember, sometimes intermediates can be hard to detect because they don't last very long. A catalyst is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. A catalyst provides an alternative, lower energy path through which a reaction can occur. Because catalysts don't undergo any permanent change, catalysts that are present at the beginning of the reaction are also present at the end. We can see this in this example, where D reacts with 2B to produce E. In the second reaction, E reacts with A to form D, C, and B. Notice that D is used up in the first reaction, but it is generated again in the second. D is a catalyst and does not undergo any permanent change. We can add up both of these reactions and get our overall reaction. A reacts with B to yield C. So, how do we tell if something's a reactant, product, catalyst, or intermediate? Well, if we're given a set of elementary reactions, we can logic our way through this. Let's take a look at this series of elementary reactions here. We can add these up to get an overall reaction. A plus 2B yields G. And we get this by crossing out common species on the left and right sides of the reaction. But let's take a couple steps back and march through this reaction one piece at a time. We know that A and B are reactants, and we determined this when we added up all the elementary equations in the mechanism. If we take a look at C, we notice that it is the product of the top equation, but it is a reactant in the second equation, and it looks like it's consumed. C is an intermediate. Now let's look at D. We see that D is a reactant in the second equation, but that in the third equation it is a product. So basically it was used up in the second equation but regenerated in the third. D is a catalyst. Now let's look at E. E is the product of the second reaction, but it is a reactant in the third. E is an intermediate. Now let's look at F. We see that F is produced in the third equation, however, it is a reactant in the fourth equation, where it is used up. F is an intermediate. And let's look at the last line. B is a reactant, but we already knew that. We have 1B used in the first reaction and 1B used in the fourth. And our product is G. And after we cross out all of the catalysts and intermediates, our final reaction equation is A plus 2B yields G. Here's another example in which we're asked to identify the reactants, the products, the catalysts, and the intermediates. Now we've added the two top equations up to get our overall equation, and we see that A and E are our reactants, and that C and F are the products. Let's take a look at B. We see that B is a reactant in the first equation, however, it's a product in the second. It is a catalyst. It is used in one equation and then regenerated in a later equation. Now let's look at D. We see that D is produced in the first equation, but it is used in the second equation. D is an intermediate. Let's summarize. A reaction mechanism consists of a series of elementary reactions or steps that occur in sequence. The components may include reactants, intermediates, products, and catalysts. The elementary steps, when combined, should align with the overall balanced equation of a chemical reaction. A reaction intermediate is produced by some elementary steps and consumed by others, such that it is present only while a reaction is occurring. Experimental detection of a reaction intermediate is a common way to build evidence in support of one reaction mechanism over an alternative mechanism.